Look up at the night sky. Our galaxy is not an island. Right now, the Andromeda galaxy is closing the distance between us, locked on a direct collision course with the Milky Way. We naturally expect a collision to be an ending. We imagine billions of massive stars and black holes smashing together, tearing both galaxies apart in a violent final explosion. Despite the immense scales and the terrifying trajectory, this encounter will likely leave the vast majority of stars untouched. This creates a strange paradox. How can two objects containing hundreds of billions of stars pass directly through one another without a single physical crash? The answer lies in the true nature of galactic architecture. We think of galaxies as solid objects, but that is an illusion created by the vast distances of deep space. From our perspective, a galaxy looks like a dense, glowing disk. In reality, it is mostly a vacuum.
While the Milky Way holds hundreds of billions of stars, the gaps between those stars are almost incomprehensibly large. If we shrunk the sun down to a grain of sand, the nearest star would sit thousands of kilometers away. Because of this vast emptiness, merging galaxies act like ghosts. Sparse fields of stars slide through one another, with almost no physical contact. Direct impacts are mathematically improbable. Instead, the interaction is governed by a much more persistent force, gravity. Every individual star, massive gas cloud, and dark matter structure pulls on every other. This turns the collision from a quick explosion into a slow, gravity-driven transformation that reshapes the local universe over millions of years. Long before the stars overlap, gravity begins warping the galaxy's shapes. Spiral arms are pulled outward, stretching into massive streams of stars called tidal tails that can reach hundreds of thousands of light-years into the void. The two galaxies engage in a long-term dance. They pass through one another, separate, and then are pulled back by their mutual gravity, losing energy until they finally begin to fuse. While stars miss each other, the same isn't true for the immense clouds of gas and dust drifting between them. These clouds are large enough and dense enough to physically collide and compress. This gravitational compression triggers an era of rapid star formation. For a few million years, the merging system becomes a starburst galaxy, glowing with the intense light of countless newly born suns. As the outer structures merge, the heaviest objects in each galaxy move toward the new center. These objects are the supermassive black holes. They form a binary system, spiraling closer until they ultimately fuse into one. This final merger shakes the fabric of space itself, radiating energy outward in the form of gravitational waves. This process converts the gravitational energy and gas of two dying systems into the building blocks for a more massive, unified galaxy filled with stars that didn't exist when the collision began. For our solar system, the merger means our position in the galaxy will shift. The sun could be drawn into the dense, bright center of the new system, or cast out into its distant, lonely fringes. The view from Earth would be extraordinary. Over millions of years, the night sky would slowly warp as familiar constellations disappear, replaced by the glowing architecture of a massive new galaxy stretching across the heavens. While Earth will likely survive this gravitational chaos, it will not remain habitable long enough to see the end of it. Earth's long-term habitability is threatened by a far more certain timeline, the natural evolution of our own middle-aged sun. In roughly 5 billion years, the sun will expand into a red giant. This expansion will scorch the inner solar system and destroy Earth's atmosphere, likely occurring just as the galactic merger reaches its peak. Long after our world is gone, the chaos of the merger will settle. The gas will be spent, the original spirals will vanish, and a single, stabilized galaxy remains. On a timeline of billions of years, the universe is never static. These collisions are the process by which the cosmos reorganizes itself, moving from old, stable structures into larger, more complex systems.